Alright, our second scenario is now adding to the head. So I'll go over the slides and show the animations they do in a bit, but the code they do differs, and I want to just explain this manually. Suppose we have, let me go ahead and make some better nodes, right? Suppose we have ourselves, one node and another node, right? And another node, right? Doesn't really matter that I can't draw, things that look the same, right? And each one is pointing to the next one, right? So this guy is storing the memory location of this guy is storing the memory location of this guy. Where is it stored? It's stored in his .next variable. Okay, so this guy currently is the head, and I'll annotate him as such. Okay, so suppose I wanted to add a new guy to a new node to index 0, right? It's this new node over here, right? And let's go ahead and say that she has the so first thing we do is make her, and then we'll call her, since we are making her, we have to give her a variable name, so we'll call her temp. Okay, so the next thing we have to do is we have to attach temp to head. So we store head in temp.next variable. Okay, then the final thing we need to do is that, well, head is no longer actually the head of the list, so we need to take that and we need to make sure that the head of the list is temp. That's essentially what we do for adding. All right, so let me go ahead and repeat the process. Right, the first thing we do to do is that we make our new node called temp. Okay, make our new node called temp, lowercase please. The next thing we do is we attach it. Right, we attach it to the head of the list, and then the third step is we make temp the new head of the list. Those are your steps to adding the new head of the list, right? Let's look at their example, right? So we have a head, we have the head of the list. It has Tom in it. It holds data that points to the next node, which contains Rich. Right, now suppose we wanted to add a node called Ann to the list. Right, so the first thing we'd do is we'd take Ann, we'd attach her to Tom, and then we'd update head to be the new head of the list. Alright, so that's what we're going to do there. So the first thing we need to do is over here, make sure that we are being consistent with size, remembering to increment our size after we do an add operation. Okay, so how do we know we're adding the node that we're adding is we're heading it to the new head? Well, if the index equals 0, then we're adding it to the new head. Otherwise, we're in the everything else scenario, which will be else. Okay, so that's all sorted out, which scenario we're at, right? If we're out of bounds, we're in scenario 1. If the index is equal to 0, we're in block 2. Else, everything else. Alright, so let's go ahead and just turn all these steps into code. And you'll be surprised that that's all we need to do. The first thing we need to do is, and then, now some of you may be thinking, wait, what if the head is null? And it's kind of brilliant, actually. Alright? Just trust me on this. Okay, I code my linked lists up in a specific way because it kind of helps a whole lot with the way I do it. Okay, so first thing we need to do is create the new node that has the item that we're adding in it. Okay, so might as well do it outside of here because we're going to need to do it for scenario for scenario 2 and for scenario 3. So node e temp is equal to new item. Sorry, new node and that node contains item. Right? This will now hold the item. Now this is a new, and this reflects this situation. Let me move this up. This reflects this situation. We've just got this standing out here. Head is over here, right? And essentially, temp doesn't know anything about the linked list yet. Head doesn't know anything about temp. Okay. So if index is equal to 0, what's the first thing we need to do? We need to attach temp to head. So the question is, how do I do that in code? Well, what I need to do, well, really what I'm doing when I'm doing this, right, is I am taking the memory location of what is currently the head and storing it in this node's .next, right? I'm taking I'm taking the memory location of the node with Tom in it and storing it in and's .next variable. All right? So this is what that looks like over here. So I'm taking the memory location of head, right? So the memory location of head is that, and I got to store that somewhere. That's what the assignment operator is for. So where am I storing it? I'm storing it in temp.next, right? There's two ways to look at it. Essentially, there's two ways to really grok this, to parse this. This temp.next gets set to head, so this effectively, so that's the whole drawing this arrow, right? This arrow over here with that line. Or the way to look at it is with the memory location where I'm taking head.next and I'm taking head and I'm storing it in temp.next. Okay. So the third step is what? I have to set temp to head now. Okay. So now the memory location of head should store temp in it. And that does it. Okay? And it's very important that that these lines happen in the correct order. If they do not, you're in for a miserable time because of Java's garbage collector, right? If you do them in the reverse order, where basically I make this guy, where this guy's the head, right? And the first thing I do is say, okay, I've created the temp variable, and I'm going to take this guy, and I'm going to make him the head of the list. Okay, it's time to attach everything else. Wait a second, you don't have a reference to anything else. So this linked list is just kind of drifting out there without a tether, alone, lost in the universe of your memory, ready to be eaten by the garbage collector. Because that's the way Java handles us. Because what happens is that now that there's no references to this object, Java just deletes it. And as a result, the next gets deleted as well. And then Java will eye this thing and go, oh, there's nothing pointing to you. Nom 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 nom. Then it will eye this thing and go, oh, there's nothing pointing to you either. And it will delete that. So if you don't do this in the right order, right, you will lose this list, right? Because you don't have any references. So this will get deleted, then this will get deleted, then this will get deleted. Okay, so by making sure that we attach first, rather than, right, by attaching first, when we switch head to be over here, we still have a memory location here, so this doesn't get deleted, which causes this not to get deleted, which causes this not to get deleted, because they're each pointing to each other. Okay, that's it for scenario 2, believe it or not. That's all you need to do to attach the new head of a linked list. We'll test it out in a second. But what about if if you've got an empty list, right? Shouldn't that be something that we need to take care of? In some cases, yes, but in the singly linked list, which is very basic to write, well, I've got no linked list. Let's follow this through. Temp.next is, so I've created a new node. It's temp. I call it temp. Temp.next is equal to head. Well, what is head? Head is currently null, so it points to nothing, right? Points to null. So temp.next is equal to head. That means it will point to nothing. And then I say head, store the memory location of temp. So make this the new head of the list. Ta-da! So this works regardless of whether you've got nothing in the list or not. Let's go ahead and test this out. Okay. Public stack void main. I'm going to go ahead and make the main method in here just to test it out. Linked list E is equal to L is equal to new linked list. And oh, can't use E here. I've got to use. Let's make it a linked list of string. Right. L dot add A. L dot add. Oh, but the add method itself doesn't work yet, so we actually need to do 0 and 0, right? So this should be BA. Right, so first we're going to run it to make sure there's no null pointer exceptions. We won't get an output other than it should finish, and if we had an error it would have just crashed and burned on us. Okay, so now we need to figure out how to print these things to confirm that they're working, which means we need to start thinking about how we can kind of go through this list. Alright, so we'll do that in the next video.